Okay, this is Module 19, Apply Triangle Sum Properties. The first thing I want you to do is take a piece of paper, and I want you to draw a triangle on that piece of paper. And cut out the triangle from your piece of paper, and I want you to, again, trace that triangle on the remaining paper and cut that out. So you should have two congruent triangles. So the thing I have to establish is what exactly is a triangle. A triangle is a figure formed by three segments joining three non-collinear points. And it's a two-dimensional figure, so it will lie on a piece of paper. That's why you can actually cut it out. Next thing I want you to do is cut the corners of one of your triangles off. Do not cut the numbers off, you must have them showing, which means that you have to give numbers. So I'm going to label this one 1, this one 2, and this one 3, because you have three what's called vertices. So I want you to place each one of the vertices so they are touching. So if you ripped this off, if you ripped this one off, and if you ripped this one off, I want you to put them so that they are touching. And each one of the numbers represents what's called a vertex. And a vertex is each of the points of the triangle, or represents each angle of the triangle. When you put these three angles together, what do you notice about them? If they don't overlap, what angle do they make? Well, they make 180 degrees, because if you did this, you'd have, for example, angle 1 would look like this. Angle 2, maybe like this. And angle 3 would look like this. So if you put them together, they make a straight line right here. That's your straight line. That's how we know that the angles of a triangle create 180 degrees. So that's actually a theorem that we're going to show in a little bit. But we have different types of triangles. Our first type of triangle, if you remember in a previous module, the word lateral meaning side and equa meaning equal, we have an equilateral triangle. It has three congruent sides. And these dash marks are a specific way to show congruency in a figure. Remember, three dash marks signify the same congruence. So, next is an isosceles triangle, and that has at least two congruent sides. So, by the dash marks, you have one congruent side here, and another congruent side here. And that signifies that those two sides are congruent. The third side is labeled with two dash marks, so that symbolizes that it's not the same as the other one, which are labeled with just one. So we call it isosceles. The parts of the isosceles triangle that are the congruent sides are going to be called legs. And the third type of triangle classified by sides is called a scalene triangle. And that has no congruent sides. So if we went from one dash mark all the way around to one dash mark for just two of the legs, now we're going to have three different labelings for the legs. One dash mark, then two dash marks, then three dash marks. That's types of triangles classified by sides. Now what about by angles? Acute triangle. That's going to have three acute angles as their vertices. So, for example, you could have a 55, 45, 80. All those numbers add up to 180 degrees, so that means it creates a triangle. And all of them are less than 90 degrees, which means that they are acute. So it would be an acute triangle. The next one is a very special one, and we actually have an entire unit that's associated with this, but we call this the right triangle, and it has one right angle. So the other ones, and this is actually a special right triangle, and again, we have a unit that's established with this as well. And this is also talked about in pre-calculus and calculus quite a bit. But it's called the 30-60-90 triangle. But the main thing that's important about this is that it has one right angle. The side that is opposite the right angle, which is the important part, is called the hypotenuse. And you should remember from probably middle school when you figured out using the Pythagorean theorem, the longest side of the triangle, of a right triangle, you would figure out was called the hypotenuse. And last one in terms of labeling, in terms of classification of angles, is something called an obtuse triangle. And that has one obtuse side. Remember what obtuse means? Greater than 90 degrees. So, for example, I could have 130 degrees, 20 degrees, and 30 degrees. Those add up to 180. And this angle right here makes it an obtuse triangle. The last one is called an equiangular triangle. That has three congruent angles. And if you think about it, if all the angles of a triangle add up to 180 degrees, what is the measure of each one of these going to be? Well, if they're all equal, that means they're going to measure 60 degrees. So an equiangular will measure 60 degrees at each vertex. We have a certain property of angles that are associated with a triangle. When angles of a polygon are extended, other angles are going to be formed. We have something called exterior angles, and we have something called interior angles. The exterior angles are going to be the angles that form linear pairs with the interior angles. So that would be these guys here, because if I were to label my interior angles as, let's say, 1, 2, 3, I'm going to take my example 1. If I were to extend 1, this angle and angle 1 both create a linear pair. And also this angle and angle 1 create a linear pair. And that occurs throughout the triangle. Next thing we have is interior angles. And interior angles are going to be angle 1, 2, and 3. So those are your interior angles right there. So interiors inside, exteriors outside, and forming a linear pair. Okay, I have to introduce a new vocabulary word called corollary, because we're going to have corollary to theorems, which are basically a statement that can be proved very easily using a theorem, the original theorem. So think of it as kind of a derivative of one of the theorems. So we have our theorems. We have a triangle sum theorem, which we actually just showed using the ripping off of the corners. Triangle sum theorem states that the sum of the measures of the interior angles of a triangle is going to be 180 degrees. If it's not, that means it's not a triangle. It's something different. The exterior angles theorem, this is one that's kind of hard to visualize. But if you have the measure of an exterior angle of a triangle, that's going to be equal to the sum of the measures of the two non-adjacent interior angles. So this is kind of where you have to extend one of the sides. So I'm going to extend this side here. And if I have angle 1 and angle 2, those are my two non-adjacent interior angles. I can call this one angle 4. So angle 4's measure is actually going to equal the sum of angle 1 and angle 2. Angle 1 and angle 2. And the corollary, this is where we first see our corollary theorem. We have the corollary to the triangle sum theorem. The acute angles of a right triangle are going to be complementary. And again, that's easily proved because we know, using the triangle sum theorem, we know one of the angles already is going to be 90 degrees. For example, this guy here would be 90 degrees. We could actually substitute that in here and use a simple substitution and then a subtraction to actually show that the two acute angles are going to add up to 90 degrees, or they're complementary. And that will always occur in a right triangle. Okay, so I have another an example using the exterior angles theorem. And this is something that you will probably see. I have seen it being asked on SATs and ACTs a few times. And so it's a pretty important concept when it comes to mathematics. So I'm looking at it's asking me to find the measure of angle JKM, which is going to be the exterior angle, this guy here. So if you use the exterior angles theorem and set up, we have write and solve the equation to find the value of x, use the exterior angles theorem. And that basically states that 2x minus 5, your exterior angle here, is going to equal the sum of the two non-adjacent interior angles. Once you do this, now it's just a matter of solving algebraically. Subtract x on both sides, add 5 to both sides, and you get x is equal to 75. Not 75 degrees, but 75. Once you find this, you know that x is equal to 75. You can actually plug it in for the x value to find out what your measure of JKM is. That's what I will do. Substitute 75 in for x, and once we do that, we get 145 degrees. And that's the measure of our exterior angle. So, we say the measure of angle JKM is 145 degrees. The other notation you can use is the measure of angle JKM equals 145. Remember your notation, degrees, and that's all.